Last section of Chapter 6 is going to be functions and their graphs. So if you have a graphing calculator, this would be a really good section for you to get familiar with it and give it a whirl. Specifically, we're going to focus on linear functions, so those should all look like lines and their graphs. Quadratic functions, which we talked about a little bit last section, so those should all look like parabolas. And then exponential functions, those will all have a little exponential growth curve, or they could have an exponential decay curve. Some terminology for you. They will use the word relation. A relation can be any set of ordered pairs, so any xy set is considered a relation. A function is a special type of relation. Each value of the independent variable, which is the x, must correspond to one unique dependent variable, which is the y. If they don't, if x has an option between two different y's, then it is not a function. Domain is going to be the set of x values that are permitted in the problem, and range is the set of y values that output as you complete your function. So for an example, if our function was the equation c equals 1.29n, our domain is all of the n values that you can use, and notice that each n value has one unique c value that will come out. So the n would be your domain, and the c would be your range. One way that you can tell graphically if a equation is a function or not is you can do the vertical line test. The vertical line test says that no matter where you draw a vertical line, the vertical line should only intersect the function in one location. So an example of something that is not a function would be a circle. If I drew a vertical line, the vertical line would intersect the circle 2 times. So that means there is more than one output per input, and that is not allowed. Lines are always considered functions. So the general form of a line is y equals mx plus b, or y equals ax plus b. They're going to start changing the notation on you, and instead of using y equals, they're going to start using f of x equals. F of x and y mean exactly the same thing, and if you want to switch the f of x out and still call it y, that is also okay. Whenever you graph a line, it's always going to be a straight line, no matter if it's going uphill, or if it's going downhill, or if it's going horizontal. And those will always pass the vertical line test. In fact, the only line that will not pass the vertical line test is a vertical line itself. So a vertical line would not be a function, but everything else that's linear would be a function. Quadratic functions we worked with a little bit in the last chapter, and the general form of a quadratic equation is y equals ax squared plus bx plus c. Anything that's in that form will either open up like a cup or down like a frown, and in no matter which case, it is going to pass the vertical line test. They will change the notation on you, and instead of using y equals, they will start using f of x equals. And again, if you don't like that, you can absolutely switch back to y equals if you prefer. Just as a reminder, your parabola can open up or your parabola can open down. This is going to depend on the a value, the number that's in front of the x squared. If the number that is in front of the x squared is negative, say for example y equals negative x squared, that's going to cause your parabola to open down. If the number that is in front of the x squared is positive, say y equals 2x squared, that will cause your parabola to open up. So here's an example of what that can look like for you. If your parabola opens up, then the vertex is going to be at the bottom of the parabola. The vertex is just the cusp that's at the bottom, and that would be considered a minimum. Notice that your parabola is symmetric, and what's happening on the left-hand side also happens on the right-hand side. The dashed red line is showing you the axis of symmetry. The axis of symmetry always goes vertically through your vertex. Same thing if your parabola opens down. Your vertex is just at the top of the parabola, but the axis of symmetry will still go straight through the middle of the vertex. One of the tasks that they're going to ask you to find is they're going to ask you to locate the vertex of your parabola, and they're going to ask you to locate the axis of symmetry. So I can show you how to do that. There's a quick, easy formula that you can use to make that happen. If your parabola is written in standard form, y equals ax squared plus bx plus c, then the way you can find your axis of symmetry is to use the formula x equals negative b divided by 2a. And they're referring to the b and the a that are in the quadratic equation. That will give you the axis of symmetry. That will also give you the x-axis of the vertex. So if you are asked to calculate the vertex, to get the x value of the vertex, you will do the negative b over 2a. To get the y coordinate, you're going to have to take the x value that you just found and substitute it into your equation to get the y coordinate of the vertex. In order to sketch a quadratic equation, there's a several-step procedure. The first thing I would do is decide whether your parabola is going to open up like a cup or down like a frown. Second thing I would do is decide what your axis of symmetry is, where your parabola is going to fold in half if you had to fold it. Next, I would locate the vertex, which is either going to be at the top or the bottom of your parabola, depending on which direction it's going to open. You also may want to find your x-intercept, your y-intercept, which is where you're going to cross your y-axis. You may want to find your x-intercepts if you have any. Sometimes you won't have any x-intercepts if your parabola is always above or always below your x-intercept. And then last, I would connect all of these points with a nice smooth parabola, using your axis of symmetry as your guide for when you should start curving the parabola. Okay, so the easiest way to do these is to have an example. So let's say I gave you the quadratic function f of x equals negative 2x squared plus 3x plus 4, and I asked you to graph the quadratic function. They may also ask you to find your domain and range, and I'll explain that after we have the graph of the function. Okay, so first thing I would do is decide whether my graph is going to open up or down. I'm going to scooch this out of the way for the moment. Okay, so the way you can tell whether your parabola is going to open up or down is you look at the a value. Since our a value in this problem is a negative number, that's going to cause our parabola to open down like a frown. Next, I would find my axis of symmetry, which is going to be where the left hand and the right hand side are the same. And the way you calculate your axis of symmetry is doing the formula x equals negative b over 2a. In this problem, our b value is 3, and our a value is negative 2. So that's going to give us a negative 3 over a negative 4. And remember, two negatives make a positive. So when you go to graph this, at the x value of 3/4, you will have the axis of symmetry. Now, next I would find your vertex. Your vertex is going to be an ordered pair with an x and a y. We already know the x value of the ordered pair is 3/4. In order to find the y value of the ordered pair, you are going to have to take the 3/4 and substitute it into your function anywhere that you see the x is located. Unless you want to do this by hand, I would let your calculator do it for you, and as long as you type it in exactly the way you see, with the parentheses and all, your calculator should give you the correct answer. I am going to do this as a fraction. The fraction value would be 41/8. If you want to do a decimal, that's the same as 5.125. I do think my math lab will require the fraction though, so just be careful and make sure you're ready for it. Okay, so we've done our first 3 steps. Next thing I would probably do is see if you can find your y-intercept. That's going to be where you cross your y-axis. You're going to cross the y-axis when the x value is equal to 0. So I would substitute 0 in for all of your x's. And you're going to notice that your y-intercept turns out to be that c value, that 4. So you will cross the y-axis at the point 0, 4. Last, I would find your x-intercept. Your x-intercept is going to be when your y value is equal to 0. So you can solve the quadratic equation, negative 2x squared plus 3x plus 4. I don't think this is factorable, so you probably will end up having to do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if I type that 3 squared minus 4 times negative 2 times 4 in my calculator, I'm going to get a 41 out of that. Okay, and so what I would do, since you are graphing, I would go ahead and just get some decimal values. So I would do negative 3 plus the square root of 41, and then I would divide that by negative 4. That will come out to be negative 0.85. And then I would do negative 3 minus the square root of 41 and divide that by negative 4, and that will come out to be positive 2.35. Then once you have all of these things, you can put them together on your graph. So we know our vertex is located up around 5 and over by 3/4. So I'm just counting by ones just for ease, okay? So I should have a vertex of 3/4, 5.125. So I'm going to say 3/4, 5.125s around here. It's the best I can do. I know I'm going to cross the, I know that 3/4 is my axis of symmetry. So whatever happens on the left side also must happen on the right side. I know that I am going to cross the y-axis at 4. Oops. So you can use symmetry to get more dots. And I know that I am going to cross the x-axis at negative 0.85, so almost negative 1. And positive 2.35. And then do the best you can to draw your parabola. Oh, you know what I did? I put the 3/4 on the wrong side of the equal sign, or the wrong side of the axis. Do over. It happens. Okay, so let's start that over again. Even your teacher messes up once in a while. So I didn't think it looked right, but you know, what are you going to do? 1, 2, 3, 4, 5, 6. So our axis of symmetry is at 3/4, so I'm going to say that's like right around here. And then our vertex is at 3/4, 5-ish. And we're crossing the y-axis at 4. And we're crossing the x-axis at almost negative 1, almost 2.5. And so using that information, we should be able to get a sketch for a graph. Okay, another type of function that you'll be working with is exponential functions. A lot of real-world problems grow exponentially. An example would be the population, bacteria. Also, things can decay exponentially, like radioactive substances, or if you're on any kind of medication, the medication in your bloodstream can also decay exponentially. The most common exponential version you're going to see is y equals a to the x. A is called the base, x is the exponent. They will switch the y out on you and call it f of x equals a to the x. When you see something in this case, if the a value is positive, you're going to get exponential growth. So as you read the graph from left to right, it should look like it's increasing over time. If they give you a specific problem about population, often they will give you an exponential growth function that looks like p of t equals p sub 0 a to the kt. P sub 0 represents the initial amount or the original population. P of t represents the amount that's going to be present after t years has gone by. A is the base and k is your growth constant. So if the k value is positive, that means you have a growth equation. If the k value is negative, you have a decay equation. Sometimes they will not use the base a. Instead, they will use the base e. E is called the natural number. So if you substituted e in for that equation, it would look like p of t equals p sub 0 e to the kt. Everything has the same meaning. It's just instead of a, you use e. E is an irrational number. It is the number 2.71828 blah, blah, blah. It's ongoing. There is no end as far as we know. So if you are doing problems with E, make sure to use the E button that's on your calculator. If not, you may have some rounding error when you go to MyMathLab. Okay, so an example of something you could encounter. Plutonium, a radioactive material used in most nuclear reactors, decays exponentially at a rate of 0.003% per year. If there are originally 2,000 grams of plutonium, the amount of plutonium remaining after T years is given by this equation. How much plutonium will remain after 50 years? So if you investigate the equation, notice the initial amount of plutonium is put in the front, that's the 2,000, and notice the decay rate is put in the exponent. That's always going to be the case. So they have told you that 50 years are going to go by, and they would like to know how much plutonium is in the problem after 50 years. So all you have to do is substitute 50 in for the t. So you're going to take your 2,000 times e, and you're going to raise it to the negative 0.00003 times 50. I would let your calculator do all of those calculations for you. And I'll do a video of me entering this in the calculator for you. Okay, so if you're going to enter this into the calculator, you would first want to just type your 2,000. Okay, and then you want to get your E entered in there. Okay, so your E is going to be located over here where you see that natural log button. The E is above it, so you're going to have to hit second and then the E. Okay, so that'll put it up there for you. If you have a fancy calculator like mine, it's going to go ahead and give you the exponent spot. If you don't have a fancy calculator, you're going to see a little caret and then a parenthesis. And I'm going to go ahead and type in the exponent. The exponent is negative 0.00003 times 50. Oops, 50. And then you can just hit your enter button, and it'll spit the answer out for you. 1997.00224. Usually, will tell you to round to the nearest whole number, so we are just going to round to 1997. So after 50 years, you will still have 1,997 of the original 2,000 units of plutonium left. Okay, often they will ask you to graph an exponential. You can also graph the exponential in your calculator if you would like to, or you can do it by hand. If you are going to do it by hand, probably the easiest way to do it is to make yourself a t-table. Okay, so I'm going to shrink this down a little bit so we have some more room. Okay, so if I want to graph y equals 2 to the x, I'm going to pick some x values. Some easy ones to pick are 0, 1, 2, negative 1, negative 2. And then we'll sketch those on our graph when we're done. Okay, so let's start with the 2. If I have the 2, basically I'm taking y equals 2 and raising it to the second power. So 2 to the second power would equal 4. If I did the 1, y equals 2 to the first power, that would come out as 2. Y equals 2 to the 0 power, anything to the 0 power is 1. And then be careful with your negative exponents. Y equals 2 to the negative 1 power does not create a negative number. It creates, the fraction 1/2. And then y equals 2 to the negative 2 will create the fraction 1/4. But again, if you want to do that in your calculator, that's totally fine. Okay, so if I was going to graph that, I need to plot the point 2, 4, 1, 2, 0, 1, negative 1, 1/2, negative 2, 1/4, and just do the best you can. And it should look like this. Okay, now don't be surprised if they ask you for the domain. The domain is just the x values that you used in this problem. This doesn't have any restrictions on x values. There's no fractions, there's no square roots, so you can use any x value any x value you want. So you can go all the way from negative infinity to positive infinity for your domain. All real numbers are in your domain. As far as your range goes, the range is referring to the y values. Now, if you look at the arrow on the right, it looks like the y values are going to grow forever, and that's true, so they'll go infinitely high. But if you look on the left, it's really weird. You're going to keep tapering closer and closer and closer to the x-axis, but you'll never actually touch it. So you're getting really close to 0, but you can't include 0, so you're going to have to use a parenthesis on that 0. So your range is all y values bigger than 0, and your domain is all real numbers. I give you one more example. Notice in this example you have 1/2 raised to the x power. This is actually going to cause an exponential decay. So if you make your t-table and you pick your numbers 0, 1, 2, negative 1, negative 2, and you substitute them in, if we did 1/2 and squared it, we would do 1 times 1 and 2 times 2. We would end up with a 1/4. And then if you did 1/2 to the first, you'd get a 1/2. 1/2 to the 0, anything to the 0 is 1. And then 1/2 to the negative 1 is also going to cause the fraction to flip, and you'll have a 2. 1/2 to the negative 2 is going to give you a 4. So when you go to graph these, you're going to get exponential decay. Negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, 2, 1/4, and it'll continue to get closer and closer to the x-axis but not touch it. So your domain is still the same, all real numbers, you can go left and right forever, and your range is also still the same. The lowest number you ever encounter is almost 0, and you go infinitely high.